Okay, welcome everybody. Thanks for coming. This is the week 4 webinar. So we're, pushing through the class and might even be a little shorter than usual. We'll see. Maybe not. Maybe there'll be lots of questions, but always happy to answer questions. So let me tell you the plan. What we're going to be doing today is I'll start out with any questions and not just start out, but throughout the whole time. We're always happy to answer questions if you have any questions. And so then after that, we're going to get into the standard normal distribution. So just let you know, the normal distribution is by far the most important distribution of all of statistics. Okay. It's it's first place and second place is not even close. So the normal distribution is the biggie. The mathematics behind it is too hard for this class, so I won't get into the heavy math, but we will get into calculating probabilities and percentiles for the standard normal distribution. Then we'll get into what's called the general normal distribution. And that is when you might have some general or some specific, some mean and standard deviation that aren't like super easy necessarily. So then we'll look at calculating probabilities and percentiles for the general normal distribution. And then we'll also have applications. I will let you know that the applications, actually, the main applications are next week. Okay, we'll do some applications or kind of applications, but next week, really, you'll understand why the normal distribution is so important. So right now, you just got to trust me that the normal distribution is the most important distribution. And next week, we'll see why. Next week's all about what's called the central limit theorem, which has something to do with that. Okay, or a lot to do with that. So I want to give you a couple of reminders. This is week 4. What's important about the number 4? Yeah. 4 is an even number, and even numbers you have an exam. So I'm going to give you just a heads up on how this exam works, because now we're in week 4, and we've already had a week 2 exam. So a percent of it, a smaller percent will be chapters 1, 2, and 3, but the larger percent will be chapters 4, 5, and 6. Okay, and the written questions, typed in questions will be chapters 4, 4, 5, and 6. So that's kind of how it works. Everything could be on the exam, but the most recent 2 weeks, so chapter 4, 5, and 6, which is last week and this week, are going to be more heavily emphasized than the chapters 1, 2, and 3. Hopefully that makes sense. I do want to give you a big heads up. When I tell you there's words you have to use, I'm not joking. You have to use them or you're going to lose lots of points. And a lot of you did not use the language that I gave in last week's webinar for the discussion assignment. Even though in last week I said you have to use this language, I screamed it. I told you you're going to lose points, but most of you just like ignored it. So just let you know, if you don't use the language that we use in the webinar that I highlight and tell you, then you will lose points. That's also true of the exam. If you don't use the language that we talked about, then you lose points for the written questions. So that's really important to know that. The other thing that should be, right in your focus should be project 1. So I know you still have a while. You still have a week from Sunday before project 1 is due, but don't wait. Don't wait too long. So you hopefully a lot of you, but you should all have already submitted your idea onto the Project One discussion board so that I can let you know changes. And there's always some changes that need to be done, or just about always. And I also recommend looking at my comments on other people's um, Project One discussion board posts, because then you'll understand kind of what works and what needs to be fixed. And that will help you in seeing what y'all need to do. So that should help you a bit too. So hopefully that makes sense. Are there any questions about anything? So around a week from today is the hope that you'll have your draft done. Okay. It could be a week from yesterday, a week from tomorrow, but don't wait too long. So after next Thursday at 8 a.m., I won't accept it. But even if it was 7:59 a.m. on that next Thursday, it might take me a while because there's a lot of you. The projects are many, many, many pages, usually 10 pages or so. So it takes me a long time to read it and give you feedback. So don't wait until the last minute or it might be too long before you actually hear my feedback. Okay, any questions? Any questions? Okay. I also want to let you know there's tutors available that can help you too. Okay. So, feel free to get help from the tutors. Feel free to get help from me. You can post on the Project One board, the Q&A board for regular questions. You can log into my office hour, my student hours. So I'm here to help out. Any questions? I'm watching the board, not seeing it. Okay, it says no questions. Again, we're in chapter 6, which is actually one of the easier weeks in terms of the chapters. I do that because you should be focusing on your project and also you have an exam. So there's a lot going on this week. But the new stuff is a little bit lighter. So what we're going to do is we're going to start out with the normal distribution. We talked about that actually in the first week. Do you remember what the normal distribution looks like? Remember the shape? So I know it's been a little while since you thought about it, but it happened. Do you remember the shape of the normal distribution? Actually mentioned it last week and the week before. It is a curve, but what's the shape of the curve? Right? Everything's a curve, basically. Every distribution is a curve. So what's the shape of the curve? Do you remember? Yeah, it's bell-shaped. Okay, it's kind of a bell-shaped curve. And again, the formula in math is, 1 over the square root of 2 pi sigma times e to the negative x minus mu squared over sigma. And you don't have to know that. What I do want you to do is get the idea. And this is a picture, and this is a picture of what's called the standard normal distribution. And let me highlight what we're looking at. The first thing is this is, and I use a language that we had from week 1. This is a unimodal distribution. Do you remember what unimodal meant? What was unimodal? We talked about that in week 1. Yeah, one highest part. Exactly. It means there's one highest part. Okay. It's also symmetric. So that means if I take this highest part and I put a line through it, and I think of that as a mirror, then the left-hand side is the mirror reflection of the right-hand side. Does that make sense? So it's perfectly symmetric. It is unimodal and it kind of looks like a bell. Notice as you get far away, it gets really low. So it's only high in the middle. Okay. Then there is the empirical rule. Okay. Sometimes called the 68, 95, 99.7 rule. So you remember the numbers. And that says that in between -1 and 1, okay, for the standard normal distribution is 68% of the area. So that means there's a probability, there's a 68% chance of being within those numbers. In between -2 and 2, there's a 95% chance of a randomly selected item being in that region. And in between -3 and 3, it's really close to like certain. It's 99.7% chance of a randomly selected item being between -3 and 3 for the standard normal distribution. Okay. Of these, any guess on which of the three are most important? One of these is much more important than the others. Any guess? All right, I don't see y'all guessing. Hopefully you'll guess. Hey, you got a 1 in 3 chance if you have no idea. I don't see you popping in. Okay. All right, we had a guess of 68%. It's a good guess, but no, it turns out the 95% is going to be the most important one for statistics. And that we'll talk about in a few weeks. Okay. So it'll be 2 weeks from now, and then we'll get into that. Okay, so after the project is all done. But then you'll see why that's important. Any questions on the shape of this distribution and the 68, 95, 99.7 rule? Okay, if not, then what we want to do is we want to see if we can come up with answers to questions. So let's suppose that Z follows a standard normal distribution. Use the empirical rule for the following. And the first is find the probability that Z is between -1 and 1. Okay. And I don't know if you remember, but last week we talked about this way of writing it down. You write Z, and then we write this tilde, and that means has the distribution that is. And then you write N for normal. And then you write 0 because the mean, which is right in the center, is 0. And then comma 1, 1 is a standard deviation. Okay, so that's how you can say this whole thing all in one little piece. Z tilde N parentheses 0 comma 1 N parentheses. What is the probability that Z is between -1 and 1? See if you can put the chat box. What is that probability? The hint is this should be pretty easy. Okay, you're close. You said 68, but the probability can't ever be bigger than 1. So it's really close, but it's 0.68. That make sense? Okay, and just let you know, if you wrote 68 on the assignments that are computer graded, it just zaps you. So make sure that when it says what is the probability, make sure that it's a decimal. Okay, probabilities can never be bigger than 1. Is that clear? Okay, any questions on how we figured that out? Because that's what this says. It says the area between -1 and 1 is 68%. So the probability of being between -1 and 1 is 0.68. Any questions on that? Okay, now we're ready to get some harder ones. Okay, this one you just look at it and write it down. Okay, so the next one is let's see, how do we find the probability that Z is less than 3? Okay, that one's a little harder because from the picture, we want less than 3, but we don't have anything here that tells us less than 3. We have something similar to it. What do we have? So what does the picture show us? Doesn't show less than 3. What does it show? Any thoughts? It's not a trick question. This is supposed to be pretty easy. Lower than 3, that's the same as less than 3, and it doesn't show that. And 4 definitely doesn't talk about 4. Okay, so let me tell you, this 99.7% is between -3 and 3. So what we can do is we can say, well, we're going to have this piece, but then we're also going to have this far left piece, less than -3. So we can write that as that is going to be 0.997, and then plus the probability that Z is less than -3. We could do that if we want, just kind of give you some examples. But then you got to figure out the probability that z is less than negative 3. And here's the way we do that. That's this area, everything to the left of negative 3, which we don't know exactly what it is, but we know in between negative 3 and 3 is 0.997. So that means outside of that region between negative 3 and 3 will be what's left over. And remember, the total probability is always 1. So what's left over will be 1 minus 0.997. Okay, but that gives us the left-hand side and the right-hand side of these little tails. We only want the left-hand side, but it's symmetric. So how do we get the left-hand side if we know the total left and right? What do we do? Any thoughts? So again, the total left and right will be 1 minus 0.997. But that'd be total left and right, and that's both sides, and we don't want to add both sides. We'll end up getting 1. We don't want that. So what do we have to do if we just want the left-hand side, and this gave left and right? Any ideas? Yeah, divide by 2. Yeah, we're going to divide by 2. And that gives us the answer. And if you want, you can always go in and type in the calculator. I just copied and pasted in Google, and you get 0.9985. Any questions? Any questions on how I came up with this? Okay, so a little bit of kind of basic geometry. Basically, you have this area and you got to like think about, well, you can write it as two patches, the middle patch and the left patch. The middle patch, we're just given. The left patch is half of the left and right combined. And the left and right combined is 1 minus the middle, and then take 1 minus the middle and divide by 2. So that's what we've done. Any questions on that idea? Okay. Now the next question. Find the probability that z is between negative 1 and 2. So between negative 1 and 2. So it's the same kind of idea, is we got to look at these as patches. Does that make sense? So what we can do is we can say, well, in between negative 1 and 2, that is between negative 1 and 1 plus between 1 and 2. Between negative 1 and 1, that was part A, that was 0.68, plus, and now what we need to do is find out between negative 1 and 2. So we're going to do the same idea. That's this patch between negative 1 and 2. If we combine this patch and kind of its mirror image on the left-hand side between negative 2 and negative 1, combine those two and divide by 2. Do you see that? Okay, these guys, the combination of these two will be between negative 2 and 2 minus between negative 1 and 1. So what we can do is we can say that is equal to, well, between negative 2 and 2, that's 0.95. But then we got to subtract between negative 1 and 1, and that's 0.68. And then divide by 2. Any questions on how that was done? Okay, then you're always welcome to use a calculator. So I'm going to go and pop in the calculator. and I get 0.815. And by the way, I figure I should let you know if you were to think that it was 0.27, that can't be right because it's got to be bigger than 0.68. Because between -1 and 2 is more than between -1 and 1. So it has to be more than 0.68. So 0.815, at least that's more. Any questions on that? I do want to give you that heads up, which I've given you before, is that it's a lot easier to watch me do it than to do it yourself. So make sure that you can do this instead of just follow me. Make sure that you can practice these and make these happen. Any questions on part C? Okay, let's go to another one. Okay, so now find the value of z such that there is a 2.5% probability of being greater than this value z. Okay. So do you think that that value of z will be positive or negative? Will it be on the left side or the right side? So it'll be negative or will it be positive? Will it be left side or right side? What do you think? If there's a 2.5% chance of being greater than this value. Yeah, it'll be positive side because 2.5% is a very small chance, right? Less than 50% for sure. And if very few are bigger than you, you're big. Does that make sense? So you're gonna be somewhere out here. Okay. Does that make sense? So what we're told is there's a 2.5% of being greater than this value. So here's what we're gonna do. We know the probability of being greater than z is 0.025. Don't forget, when you take 2.5% and turn it into a decimal, you have to move the decimal over twice. The first one would make it 0.25, the second would make it 0.025. All right? And that would be, whatever that value z is, that would be that far right side. So now what I'm going to do is I'm going to combine the far right and the far left as the mirror image. So if we know the probability of being greater than z is 0.025, then the probability of being less than negative z plus the probability of being greater than z is double 0.025, which is 0.05. Any questions on that idea? All right. So if the probability of being on the left or the right is 0.05, then the probability of being between, so x being between negative z and z, is 1 minus 0.05, which happens to be 0.95. But now, 0.95 tells you we're in this region. But we also know that it's going to be on the right-hand side, so the answer is going to be 2. And there's my answer, 2. Anyone lost on what we just did?
Yeah. What'd you do with my crops?
Huh? Any questions? Okay, so z equals 2 is that probability. So the idea is that if you're only looking at the left-hand side, you want to make left and right together because that's what we can do with these kind of problems. Because the opposite of the left and right together is the middle part. And the middle is what this empirical rule gives us. Do you see how that works? So that's how we take just right side and make it right and left, and then subtract from 1 and make that middle. Yeah, so it's very visual, but you have to see it. All right, let's do the next one. Okay, so now we want to find the 16th percentile. Who remembers what it even means to say the 16th percentile? What does that mean, the 16th percentile? You remember? That happened a few chapters ago. Chapter 2. Do you remember what it means to say the 16th percentile? I don't see you all jumping in. Okay, let me remind you. Something higher than 16%. So I'm not sure about something higher, but it means the value of z so that 16% is less than that value. Okay? By the way, if 16% is less than the value, are you on the left side or the right side? Yeah, you're on the left because if only 16% is less than you, you're small. Do you see that? Because 16% is not a big percent. So not much is less, which means you're on the small side. So that's just a note, you're on the small side. So we're going to do something very similar to what we just did. So 16 percentile will be negative. Okay? Similarly, that means if the left side is 16%, we go to the right-hand side, that's 16%, put those together, and 16 plus 16 is 32, right? So 6.16 plus 0.16 is 0.32. The probability of not being on the left or right will be 1 minus 0.32, which happens to be 0.68. And then you just go and look at the picture. 0.68 is between -1 and 1. We're on the left side, so the answer is -1. It's actually very similar to the other one we had just done. So z equals -1. Any questions on these ideas? Okay, let's do the next one. All right, if z is 1.3, find its z-score. Remember the z-score. Let's see if you can put it in the chat box. What is the z-score if the value is 1.3? Remember there was a formula. I'll remind you of the formula. It's x minus mu over sigma. In this case, it's z minus mu over sigma. What do you get if you plug it all in? The hint is it's pretty easy. Shouldn't take more than a few seconds, actually. So if z is 1.3, so the value is 1.3 on this curve. That's just around here somewhere. What's the z-score for that value? You can pop in the chat box your answer. Seeing a few answers. Okay, let's take a look. Some of you got it, some of you didn't. Okay, so z is x minus mu over sigma. X is 1.3. Mu is 0, and sigma is 1, because it's a standard normal distribution. 1.3 minus 0 is just 1.3. 1.3 divided by 1 is still 1.3. So guess what? If I started with 1.3 for our value, the z-score is still 1.3. But there's nothing special about 1.3. I could give you any number, it would do it. That is actually why we use the letter z for the standard normal distribution, is it's its own z-score. Any questions on that? Because the mean is 0, standard deviation is 1. Subtract 0, divide by 1, you haven't changed anything. Is that clear? Okay, let's do some more. Okay, now it's going to be a bit different. Suppose that x follows a normal distribution with mean 114 and standard deviation 23. So notice this is not a standard normal distribution because the mean's not 0 and the standard deviation is not 1. This is its own special normal distribution. Kind of the same idea of the shape, still bell shape, but it's going to be very far to the right in terms of where the center is, and the standard deviation is 23, so it's wider. Okay, so the first thing is we can write x tilde. Now I'm going to write n, parenthesis 114, that's the mean, comma 23. Okay, and the question is find the probability that x is between 100 and 120. Okay, any guess on how we're going to do that? Any thoughts? Okay, I'm not hearing it. So let me remind you, if something's really hard, there's some good news. That is, we use a calculator. Okay, so what I'm going to do is I'm going to go to the calculator. Okay, and I do want to note, you need to use this calculator for your exams and your assignments. The only thing you don't use this calculator for is for the project, and that you use a spreadsheet calculator. For everything else, you should really use this calculator. Okay? Because if you do it by hand, you're going to have all kinds of rounding errors and you're going to lose points. So use this calculator and it'll get you, because when I check to make sure you get it right, this is what I use. This is the calculator, and this gives you lots of decimals. Okay? It's good accuracy. So what calculator do you think I'm going to use? Which of this list? Which calculator number? Yeah, it's number 9, because we're doing the normal probability. Remember, it's in the order at which we do things. Last week we did binomial and expected value. Now we're on normal. So I'm clicking normal probability. Okay. It says first decide on less than, greater than, or between. Then fill in all the values except one below and hit calculate. The last value will then be given to you. Okay, we want the probability that x is between negative 100 and 120. So I'm going to click on between because that's what we want. Any questions on that? And again, x is between 100 and 120. So I'm going to type in 100 for the left-hand side of between and 120 for the right-hand side. Then we're given that x is normally distributed with mean 114 and standard deviation 23. So 114 and 23 are the mean and the standard deviation. Okay. We leave one blank, that's the probability, because we want the probability. Then we hit calculate. Okay. And we're given the probability. The other thing, I did this I changed these the last year or so, is I made this picture nice. So you get a nice little picture of the probability. And I also made it easier to use. I won't get into that, but someone had a suggestion. And you get about 0.3315 to 4 decimal places. You can go all these decimal places, but no one cares about that many. But 0.3315. So the answer is 0.3315. Any questions? Any questions on how I got this into the calculator. Okay, I will let you know if you had to do this by hand without a calculator, mm, this would be brutal. Don't even think about it. Okay, I'm not even going to go there in terms of explaining how, because the math is really intense. So we're not doing it. Sound good? So even if you have like, first semester calculus or whatever, that you still can't do it. Any questions on how I got 0.3315? Not too terrible? All right. Let's find the probability that x is greater than 200. So we want, again, probability x is greater than 200. So what needs to change here? Okay, 200. But before I do that, I don't want between. Do you see? I want greater than. Okay, greater than, not less than, greater than. Does that make sense? The symbol, it's important that you know that this symbol means greater than. So I click greater than symbol, and then I need to put in the 200 because we want the probability that x is greater than 200. What else needs to change? What else do I need to do? So take a look at the calculator. What do I have to do before I hit calculate? I'm not ready for calculate yet. Change the mean. Actually, the mean didn't change, right? We're still mean 114. That didn't change for part B. Yeah, I need to erase the probability because I want the probability, which means that needs to be left blank. Does that make sense? And then I can hit calculate, and it's a very small probability. 0.0000923289, 5, okay, which shouldn't be too big a surprise because the mean is 114, standard deviation is 23. So if we go up a standard deviation, that'd be 137. You're not even close to 200. You're gonna have to go a bunch of standard deviations up, which means you're gonna have a very small chance of being that high. So it's point one, two, three, 4 zeros before the 9, 2, 3. I'll leave it at that. So it's 0.1234, 9, 2, 3. Any questions on part B? Okay. Part C. Find the probability that x is less than 90. So what should I change? What needs to change? Okay. The thing I need to change first, yeah, I need to click less than. And then I put 90. And I need to erase the probability. And I hit calculate. And it gets 0.1484 rounded. 0.1484. Any questions on that? Okay. Do you remember how to read this guy? This P parenthesis x greater than 105, and a little vertical line segment, x less than 125. Yeah, that little vertical line segment means given. So we have what's called a conditional probability. Then you got to remember we had a formula when we had a given problem. So let me pop in a formula. Image table, blah, blah, blah. One more time. There we go, equation. So that formula was a division, if you remember. And the first is the probability of both of them happening. So x greater than 105 and x less than 125. I can write that as 105 less than x less than 125. And then I divide it by the probability of the given, which is x is less than 125. Do you remember doing this? So now we actually have two things. First is x is between 105 and 125. So I'm going to click between, make it a 105 and a 125. I want the probability and hit calculate. And you get 0.33598 about. But then I need to divide by the probability that we're less than 125. So I need to click less than. 125 looks good. Erase the probability. Mean and standard deviation aren't changing at all in this question. And I get 0.68377. And then I can copy that. I can pop in this calculator. And I get 0.49136, or about 0.4914. Any questions? It's a little review. We're using stuff in chapter 3 now. This given stuff. Any questions? Okay, next one. Find the IQR. Who remembers what IQR means? Yeah, it's the interquartile range. Who remembers a formula for the IQR? For the interquartile range? Remember? It was Q3 minus Q1. Yeah, there we go. That was the formula. And now we need to find Q3 and Q1. How am I going to find Q3? What do I have to do with the calculator to find Q3? If you know what to do, it's really easy. If you don't, you're not going to get there. Do you remember to find Q3, the third quartile? Okay, I'm not hearing y'all jump in. So the third quartile means 75% is below that value. Okay, so that means there's a 0.75 probability of being below the value, and we want to find the value. So in this case, we know the probability is 0.75. And below means less than, and the value is what we don't know. So now I'm going to make that value blank. mean and standard deviation don't change, and hit calculate. And you get 129.513 about. So 129.513. Okay, now I want the first quartile, Q1. What do I have to change to get Q1? That should be pretty easy. Yeah, I need that. Instead of 0.75, you make it 0.25. And I'm going to blank out the what we're less than and see what it is. 0.98487. 98.487. And I subtract. I can copy those guys, pop it in. Oh, wait. There we go. And you get 31.026 about. Any questions? Any questions on finding the IQR? Okay, so let me do another one. Okay, the middle 84% of the data is between what two values? Okay, so here's how we do that. The middle 84%, we don't know what two values it's between, but if the middle is 84%, then 1 minus 0.84 will give you the outsides. 1 minus 0.84 is 0.16. Okay, so the left-hand side will be half of the outsides. So that'll be 0.16 over 2, which is 0.08. Any questions on that so far? Okay, so now 0.08, if I go in here, that's a left-hand side probability is 0.08. And we need to find that number. So I leave that blank and I calculate. And I get about 81.6835, etc., or about 81.68. Okay, the right-hand side will be the same idea. Okay, if you want, if there's an 8% on the left, 8% on the right, I can also just change that less than to greater than and make that blank and that'll give me the right-hand side, 146.3166, etc. And that's what I get, 146.32. And that's rounded. Any questions on that? Okay. Let's see if we can find the z-score for the value when x is 117. Okay. Now we're not finding a probability, so we're not going to use that calculator. Now we're just going to use a formula, x minus mu over sigma. So I'm going to insert an equation, divide. The x is 117. The mu was 114. And the sigma was 23. Okay. And you get, I'll write as a fraction, 117 minus 114. I could do that one in my head. That's 3. So I'm going to make a fraction. So 3. And that's over 23. I'll leave it as a fraction. You could do decimal if you want. When you're doing the assignments, it'll let you know whether it wants decimal or fraction. Any questions on finding the z-score? Is this an outlier, by the way? Is 117 an outlier? What do you think? Is 117, is that an outlier? It's either yes or no. Yeah, the answer is no, because outlier, we have to be greater than 2 or less than -2. Well, 3 over 23 is not bigger than 2. And it's not negative, so it can't be less than -2. So this is not an outlier at all. Okay, it's pretty close to the mean. Any questions on the z-score question? So a lot of stuff that we've already done. Okay, you ready for an application? Okay, so here's a nice little application. Okay, suppose that the time until you, or your wife if you're male, will give birth is normally distributed with mean 140 days and standard deviation 7 days. So by the way, we can write x tilde n 140 comma 7. Okay. By the way, kind of in, standard way of telling people, if what would you tell your friend if the mean was 140 days? What word would you use? You wouldn't say mean is 140 because they wouldn't understand what you're talking about. What would you say? This is this is a real life question. You wouldn't say average. It's not what people use, not for having a baby, not for giving birth. Yeah, due date. Yeah, that's what people use for this. So the due date is 140 days from now. Does that make sense? Okay. I will tell you that in the old days, the standard deviation really would have been 7. Anyone know why it's not 7 anymore? Standard deviation actually is less than 7, but it used to be 7. That's a human thing. But humans have changed. You know why? Any thoughts? Yeah, more health services, but in particular C-sections. What happens is if the baby gets too big, they just pull it out. The old days, they didn't do that. So in the old days, it really was a 7-day standard deviation and it was approximately normally distributed. So that suppose is really for the old days. Now there's some medical things that are different. So if you don't use any medicine, if you don't have any medical issues, then it really is about normally distributed with standard deviation 7. Okay, that's just a kind of a cool thing, especially if you're in the health field. Okay. And it's just some random thing that has happened in 1 week. I have no idea why, but it is. It's a human thing. Okay, so here's the question. Okay, your boss has just scheduled you or your wife for a business trip out of the country. You or your wife leave today and will return in 135 days. Find the probability that your baby will be born out of the country. Okay. So the first thing we have to do, the first thing I recommend is writing down the distribution in symbols. So we're first has an X, and then we're going to have a tilde. Okay, we're assuming that we have a normally distributed distribution because that says so right here. And because it's normally distributed, I can write an N. That's normally distributed. And then the first number that comes in the symbols is the mean, which is 140. Then comma. The second number is the standard deviation, which is 7. So one of the hardest parts about this class for a lot of people is to take what's given and turn it into math symbols so that we can put it in the calculator. The calculator itself isn't hard, but there's a lot of stuff that's useful, which means you're going to see paragraphs and you're going to have to like figure out what it's asking and turn it into the math that you need. Okay, because these are real life things that happen. This is, you know, this stuff really does happen. We want the probability, so I'm going to write P, parenthesis, that your baby will be born out of the country. If the baby's born out of the country, when was it born? What can you say about the when it's born? So in other words, what do I write? What symbols do I write here? I don't see everyone jumping in. Yeah, so it's X is less than 134. Because if the baby is born before 130, sorry, not 134, 135. Okay. We're gonna let being in the airplane out of the country too. Sound good? We'll call that out of the country. So anything less than 135 will be out of the country. Do you see? Because you're gonna return in exactly 135 days. So if it's 134.9, that's still out of the country. Do you see that? Okay, so now the good news is we did problems just like this. So I'm going to go back to the calculator. We have our mean 140, standard deviation 7. So now I'm going to write 140 for the mean. Standard deviation is 7. We want the probability that it's less than 135. So I click less than, and then 135. I want the probability, so probability is left blank. Let me know if you anything you don't understand. And then I click calculate. And there it is. There's about about 0.2375. I'll go two decimal places. That's probably enough. 0.24. Okay, by the way, let's let's say, you really hope that, someday, maybe in 50 years or so, you want your baby to be the president of the United States. Okay. Would you be okay if there was a 24% chance that your baby's born out of the country? What do you think? Okay, probably not. Okay, 24% chance is a pretty high chance. So here's the deal. So you decide it's too risky. Okay, so instead of quitting, you're going to negotiate with your boss. Sound good? To ensure there's no more than a 1% chance that the baby's going to be born out of the country. Because you figure, hey, if it's less than 1% chance, it probably won't happen. What day should you ask to be the return date? Any questions on the question? Okay, so now we want the probability that X is less than we don't know. But that probability should be 0.01, 1%. Any questions on how I took this sentence, okay, or these two sentences, and turned them into math notation? Any questions on that? I do want to let you know it's a lot easier to watch me do it than to do it yourself. Okay. But hopefully it makes sense because if you want no more than 1% chance, that's the probability, 1%, which is 0.01. We don't know the day. We want to find out the day of the return date, Remember that 135 for the last question? That was the return date. That's what we don't know. So I'm going to put a question mark in the don't know area. And now I can just use my calculator. I want the probability to be 0.01. I don't know the return date. I don't know what I want it to be less than. That's what I want to find out. The mean and standard deviation haven't changed at all. So I hit calculate. And I get 123.7, maybe 124. So ask to return in 124 days. Okay. If you want to negotiate, you might want to say 123, round down so you can plead with your boss. And then it'll be less than instead of greater than. That would be 123 to make it less than. Any questions on this idea? Okay, see how important this is? This stuff really does happen, by the way. Okay, these are situations that really can happen. Okay, so here's the next question. Okay, now let's look at the situation and let's say now it's 138 days later. The baby still hasn't been born. Okay? Find the probability the baby will be born in the next 24 hours. What kind of question is this? Because that's some part of the hard parts is to decide what is it? What kind of question? What kind of probability question is this? I don't see you all jumping in. Because again, you are going to be responsible for knowing how to, read a sentence like this and turn it into a probability with symbols. Okay, so we know it's definitely not binomial. Binomial is yes or no. This is not yes or no because this is time and time is not discrete. Okay, so this is going to be a conditional or a given probability. So we want the probability that the next 24 hours means day 138 to day 139. So 138 is less than X is less than 139. And we're given that X is greater than 138. Any questions on turning this into conditional? Okay, so now that we have this conditional, what I can do, let me add some math. I can write that as a probability that both occur. Well, if it's in between on day 138 and day 139 and it's greater than 138, that's the same thing as just saying it's in between 138 and 139. So probability that 138 is less than X is less than 139 divided by the probability that X is less than 138. Sorry, X is greater than 138. Let's make it bigger. Any questions on how I came up with that? All right, well, let's do between 138 and 139. I'm going to click between. I want 138 and 139. Probability is what I want, so I leave that blank. And I click calculate. 0.055653. I think I'll just copy and paste it. It's faster. Divided by, and probability X is greater than 138. So I click greater than 138. And I erase the probability and click calculate. And you get 0.612415 or so. And now I can pop that into calculator. And 0.09 is the probability around. So about a 9% chance that it'll be born in the next 24 hours. Any questions on that? Okay, one more example. Okay, now let's suppose it was a warm day today, so you probably want ice cream. Okay. And let's suppose that the amount, let's suppose you decide you're gonna have an ice cream store. Sound good? And let's suppose that the amount of ice cream that you sell each day is normally distributed with mean 950 ounces of ice cream and standard deviation 120 ounces of ice cream. So we can write x tilde n 950 comma 120. So the first question is find the probability on a randomly selected day you'll sell between 900 and 1,000 ounces of ice cream. So we want the probability that x is between 900 and 1,000. So I want between 900 and 1,000. Our mean is 950, standard deviation is 120. Probability is what we want, so I leave it blank. And then calculate. And about 32% chance, about 0.32. Any questions? Any questions on how I did this? Okay, let's look at another question. Same stuff, just another question. Let's do it this way. All right, let's suppose that in the morning you took stock of your supplies. You noticed you have 1,100 ounces of ice cream in your store. What's the probability you're going to run out by the end of the day? Okay, so just note, if you have 1,100 ounces of ice cream, running out means that more than 1,100 of ounces of ice cream is asked for by your customers. Does that make sense? Because if your customers want, total more than 1,100 ounces and you only have 1,100 ounces, you're running out. Does that make sense? So we want the probability that X is greater than 1,100. So the good news is I just click greater than, make it 1,100, get rid of the probability, and hit calculate. 0.1056 about. Okay, so about a 10% chance of running out. Do you think that's okay, by the way, if that's your business? Maybe close to 11% chance of running out. Okay. If you run out of ice cream, then what's going to happen? Customers are going to come in, want ice cream, and you can say, "Oh, we're all out," and they're going to be pissed, and your business is going to go down. Does that make sense? You do not want a high chance of running out of ice cream if your store is an ice cream store. Is that clear? Little business advice. That would be very not a good thing. So let's suppose you want to be 99% certain that you're not going to run out of ice cream. How much do you need to have in stock at the beginning of the day? Okay, so the idea is probably wasn't enough to have 1,100 ounces. You're probably going to need more ice cream. Does that make sense? So what we do is we write this as a probability question, probability that X is greater than, and that's what we don't know. That's what we need to stock. And we want that to be equal to 99% or 0.99. Any questions on what I just did? So now I just go to the calculator. Want the probability to be 0.99. We want to find out what number, the probability of X being greater than what number. So I leave that blank and everything else is good. And I hit calculate. Oh, you know what? Sorry about that. If you want a 99% chance of not running out, then it's a 0.01% chance. Sorry about that. 0.01% chance of running out. That's better. And you get 1,229, okay, 0.1617 or 1,220 of 1,230. I'll round it up. So I'm going to have 1,230 ounces of ice cream. Yeah, so you have a choice. You can say, hey, you're only going to have a 1% chance of running out, or you could say 99% chance of not running out. And if you did 99% chance, then it would be a less than what number? And you'll get the same answer. Does that make sense? So you have a choice. They give you the same thing. Because if there's a 99% chance of being less than that number, there's a 1% chance of being more than that number. One thing about what is the probability? Just pop it in. Of having exactly, how about 1,000 ounces sold? So in this case, it's not a less than, it's not a greater than, it's between. Exactly 1,000 is between 1,000 and 1,000. And we want the probability. And if I calculate, you get 0. So I want to let you know, and this is really important, when you have a continuous distribution, the probability of being exactly any number is always 0. And that is because exactly this number over here is a line and the width is 0. The width is 0. The height might be big, but the width is 0. So you're always going to get 0. Yeah. So whenever you have a continuous distribution, exactly any number's probability is always 0. So that's why you notice in this calculator, you don't even need to think about it. If if I just asked you what's the probability of being exactly 1100, that would be zero. I don't have to even hit compute. Any questions? Okay, I did promise that we'd finish a little early. Let me give you the secret word. The secret word for this webinar is symmetric. I would write it down. Got to spell it right. Symmetric. So the secret word for the week 4 webinar is symmetric. So hopefully you have that. And I do want to mention something, and that is the the project that's going to be. I know it's not due for a little, for another 12 days, but you should have lots of progress. You should, in the next 5 or 6 days, you should have a draft. You should have it written, and then I'll let you know what needs to change, and then you can fix it. So this is the week you really should be working heavily on the project. Okay. You only have one chapter to do. It's not a hard chapter. So it's not that much of that. Really, the project is what you're going to be doing a lot. The hope is you get your data collected, you do your surveying. I do want to mention something, and I put in the chat in one of the discussion boards. If if you're going to be surveying, say a a class out of your college, okay, could be Lake Tahoe Community College. You should always ask the instructor first before you survey, get permission. The instructor will almost always say yes, but you should always ask for permission just so you're not, bothering the instructor. So that is important. So it's always a good idea to ask the instructor. Another thing I recommend, if you're going to be, let's say you're going to be surveying, people in front of the Safeway supermarket, then what I recommend is the very first thing you should do is say, I'm a student from, at college and I have this project for my statistics class that's really hard. Can you answer a survey question so that I can get data for my project? And then they'll almost always say yes because they'll feel sorry for you. Okay. If you don't say that first, then a lot of people will just walk away when you ask the question. Does that make sense? So that's just a suggestion to make it easier to ask a survey question, especially if it's some random public place, whether it's near market or a park or whatever. It's always better to say that you're doing it for your college class that you're taking, your college statistics class. You can even say it's really hard, even if you don't think it is. So that's a couple suggestions about conducting surveys is that if you tell them that you're a statistics student and it's for your statistics project, you'll have a really good success rate in getting people to answer your survey question. Also, if you're going to do it in a class, it's a lot easier to just get a whole bunch of paper, small tiny pieces of paper, and hand the paper to everyone. Tell them the survey question, say write down your answer, which will just be a number, and then walk around and pick up the paper. That's a lot faster than asking everyone one at a time and writing it down one at a time. Let them do it. Does that make sense? So it's just some suggestions for having a higher success rate in surveying. And remember, no children allowed. You can't ask children. You can't go to a second grade class and ask a second grade class. That's way against the law. So I think I'm going to call it. I told you we finished a little earlier. It's 7:19. But I'm always happy to answer any questions you have. So let me stop the recording. Thank you for coming.